Hey everyone! Welcome back to the channel. In this video, we're going to learn how to create a JPA entity in Spring Boot, step by step, with a full explanation, in a super beginner-friendly way. We'll cover what an entity actually is, how to define it, and how it maps to your database table, all with practical code examples. So, if you're new to JPA or just want a clear understanding of how entities work behind the scenes, you're in the right place. Let's dive right in. Alright, so first, let's quickly understand what an entity is. As I already mentioned in the previous video, an entity is just a regular Java class that represents a table in your database. Each object or instance of that class represents one row in the table, and each field in the class maps to a column in that row. Alright everyone, remember that employee class we've been using as a simple POJO with JDBC template and named parameter JDBC template? We'll turn this plain Java class into a JPA entity so it maps directly to our employee table. All it takes is a few annotations, and suddenly our class will know exactly how to talk to the database. Let's jump in and see how easy it is. Okay, first up, let's open our pom.xml. Right now, we only have the JDBC starter dependency, but to use all the awesome JPA features, annotations, entity manager and more, we need the Spring Boot starter data JPA. Replace the Spring Boot starter JDBC dependency with Spring Boot starter data JPA. Alright, you might be thinking, wait, did we just break all our JDBC template or named parameter JDBC template code? But check this out, when we swapped in the data JPA starter, it automatically brings in the JDBC starter. That means all your existing JDBC code still works perfectly. And another bonus, by adding the Spring Boot starter data JPA, you not only get JDBC but also all the necessary JPA dependencies, like Hibernate, the JPA API, and other required libraries, automatically. So you're fully equipped to start using entities and the entity manager without adding any extra jars. Alright, now let's open up our employee class. We've already been using this class to interact with our database using JDBC template and named parameter JDBC template, right? But now we're going to take it one step further and turn this into a JPA entity, so we can let Entity Manager handle all the database operations for us automatically. Cool, right? Okay. So JPA provides this special annotation called @entity, as you can see right here on the screen, and it comes from the Jakarta.persistence package. As soon as you put @entity on top of your class, that's it. This class is now officially an entity. This annotation tells JPA, hey, I'm now an entity. I'll be mapped to a database table, and my objects will represent rows in that table. Okay, now put the @entity annotation on our employee class. It's done. Our employee class is now recognized by JPA as an entity. Now you might be wondering, how does JPA or the entity manager know what the table name is for this class? Well, if we don't specify anything, JPA follows a convention. It automatically converts the class name into a lowercase, camel case style table name. So, for our employee class, JPA would convert it to something like employee as the table name. For example, let's say you have a class named UserAddress. In that case, JPA would automatically convert the class name into user_address as the table name. Alright, so now imagine this. What if the name of your class and the name of the table in the database are completely different? Don't worry. JPA has got you covered with the @table annotation. So, the @table annotation allows us to specify the exact table name we want to use. You can give the table any name according to your database design or preference. If your table name differs from the class name, this is where you'll use it. JPA will then pick the table name for this class from this annotation, and that's it. No confusion, no mismatch. Let's say you want to use the table employee_data instead of the default employee. We simply add a table, name equals employee_data, at the top of the class, and JPA will handle the rest. And here's why it's super handy. I prefer using the @table annotation because if in the future you decide to change your class name or the table name, they won't mess with each other. This keeps things clean and easy to manage. See my screen right here. Add the @table annotation on our employee class. And specify the table name as employee. Okay, now we're done with configuring the table name. But what about the column names? Well, if we don't specify the column name, JPA follows a similar convention. It automatically converts the field name into a column name using a lowercase, snake case style. So, if you have a field called employee name, JPA will convert it into a column named employee_name by default. But what if we want to customize the column name? No worries. JPA provides another annotation called @column where we can specify exactly which column we want the field to map to. So, let's say you want the column to be named EMP_name instead of the default one. With @column, name equals EMP_name. You can do that easily. Alright, let's dive into the @column annotation. This annotation is super useful when you want more control over how your entity fields map to database columns. The @column annotation comes with multiple options that allow us to customize things like column name, length, nullability, and more. First, let's talk about the name property in the @column annotation. This property allows us to specify the exact column name in the database. For example, if the field name in your entity class is different from the column name in your database, you can use name to map them correctly. Next up, we have the unique property in the @column annotation. This property allows you to specify if a column should have a unique constraint in the database. By setting unique equals true, you tell JPA that the values in this column must be unique across all rows in the table. Next, let's talk about the nullable property in the @column annotation. This property allows you to specify whether a column can accept null values. By default, columns can accept null values, but if you set nullable equals false, you're telling JPA that this field must always have a value, and it can never be null. Next, we have the insertable property in the @column annotation. By default, this is set to true, which means JPA will include this column in the insert query when you save an entity to the database. But what if you don't want JPA to insert a value into a column? That's where you can set insertable equals false. For example, let's say you have a created date column. You might want the database to handle the value for that column, like setting the current timestamp automatically when a new record is created. In this case, you don't need to provide a value for created date in your entity because the database will update it for you. So, if you set insertable equals false for the created date field, JPA will not include it in the insert query. Alright. Next up is the updatable property in the @column annotation. It works just like insertable, but for update operations. By default, updatable equals true, which means JPA includes this column in the update statement when you're modifying an entity. But if you set updatable equals false, JPA will exclude this column from all update queries. For example, again, think of our created date column. Once the value is set by the database during insert, we usually don't want to change it ever again. So we mark it as updatable equals false. Alright, next property is column definition, and trust me, this one's actually quite powerful. So, what does it do? Well, column definition allows you to manually define the exact SQL column type and constraints that JPA should use when generating the table, especially during DDL, data definition language operations. When JPA auto-generates your schema, it normally picks the SQL types based on the Java field type. But if you want full control, like defining a specific SQL type or adding constraints, this is where column definition comes in handy. Now let's talk about the table property of the @column annotation. Yeah, this one's a little less commonly used, but still pretty interesting. So what does it do? The table property allows you to map this column to a secondary table. Not your main table defined by the @entity, but some other table connected to this entity. For this to work properly, you also need to use another annotation called its secondary table on the class level to define how the two tables are linked together, usually via primary key. So unless you're dealing with more complex table structures, you'll rarely use the table property in day-to-day coding. Now moving on to the next property inside the @column annotation, and that is length. So what's the job of this one? The length property is used to define the maximum number of characters allowed for a column, and it mainly applies to string type fields. By default, if you don't mention anything, JPA assumes the length to be 255 characters. Next up, we have the precision property. And this one's super important when you're working with decimal numbers, especially for things like prices, salaries, or currency. The precision property defines the total number of digits allowed in a number, both before and after the decimal point. We just talked about precision, right? Now let's complete the duo by talking about scale. Because precision and scale always go together. Oh, what does scale do? Scale defines how many digits are allowed after the decimal point. Alright. So now that we've gone through all the properties of the @column annotation, it's time to add @column annotations to each field in our employee class. Okay. Look at the screen now. Add the @column annotation to our employee ID field, and in the name property, we'll pass employee_ID. This tells JPA to map this field to the exact column employee_ID in our database. Alright, now here's something very important. When we define a class as a JPA entity, it becomes mandatory to tell JPA what is the primary key of this table. Without this, JPA won't know how to uniquely identify each record. For that, we use the @ID annotation. This tells JPA, hey, this field right here is the primary key for this table. Okay. So in our case, employee ID is the primary key of our table. That means we need to mark this field with the @ID annotation. And if your table has a composite primary key, like a combination of 2 or more columns, JPA provides ways to define that too, using embedded ID annotation or ID class annotation. Alright. So here's something super important to keep in mind. Whenever you're defining a class as a JPA entity, you must tell JPA which field is the primary key of your table. And to do that, you can use either @ID annotation for a single field primary key, @embedded ID annotation if you're embedding a key class, or @ID class annotation for composite keys using a separate class. Now, why is this important? If you forget to declare a primary key, your application might not even start, because JPA needs a unique identifier for each record. Without it, it doesn't know how to fetch, update, or delete rows. Okay, great. Now that we've marked our employee ID as the primary key, let's talk about how that ID gets generated. In our case, the employee ID is auto-increment, which means the database will automatically assign the value whenever a new row is inserted. Now here's something cool. Even if we don't explicitly tell JPA how to generate it, it will still work because JPA is smart enough to figure it out based on the underlying database and the JPA provider, like Hibernate. But it's always a good idea to be explicit and clear, especially when working in real-world projects or with teams. Alright. So now, let's tell JPA how our employee ID should be generated. To do that, JPA gives us a special annotation called @generated_value. This annotation tells JPA that we want the value of the ID field to be generated automatically, like an auto-increment in the database, or maybe using a sequence or a custom generator. Alright, now if you see on my screen, this @generated_value annotation provides two main properties. First is strategy. This is where we tell JPA how the ID should be generated. Okay, now let's talk about the different generation type options available in JPA. See on my screen, there are 5 types we can use with the @generated_value annotation. Let's go through them one by one. First up, generation type .table. Table is the most portable strategy because it works with any database, even those that don't support sequences or auto-increment. It creates a separate table that stores and manages ID values. That said, it's slower and not commonly used today unless you're working with an older or unsupported database. Alright, to use this generation type .table, we need a little extra help. We need to use another annotation called @TableGenerator. This annotation tells JPA how to manage the ID generation process. And here's the important part. The name attribute in @TableGenerator should match the generator attribute in @Generated_value. Both must have the same value, otherwise, it won't work. You can see the example on my screen. Now, let's move on to the next generation type, sequence. Generation type.sequence is used to generate unique primary keys by leveraging a database sequence. A sequence is a database object that generates a series of unique numbers, and it's commonly used to generate IDs for rows in tables. When you choose generation type.sequence, you're telling JPA to pull your IDs from a specific database sequence. To set this up, you add a @sequence generator, giving it a name, your own identifier, and the sequence name, the actual DB sequence. Then, in @Generated_value, you refer to that same generator name. And here's a crucial tip. The generator attribute in your @Generated_value must exactly match the name you've given in your @sequence generator. No typos, no mismatches, otherwise JPA won't know which sequence to use. You can see the example on my screen right now. Next up is generation type.identity. This strategy tells JPA, hey, just let the database handle ID generation using its auto-increment feature. No extra setup needed. Since our employee_ID column is already defined as auto-increment in the database, identity is a perfect fit. You only need to specify the strategy, nothing else. JPA will simply use your database's auto-increment column for ID generation. That's it, no extra annotations needed. Okay, next up, UUID generation for IDs. This is perfect when you need a globally unique identifier instead of a numeric sequence. And the best part? You barely have to do anything. Just like with identity, for UUID generation you only need to specify the strategy, generation type to UUID, and JPA will handle the rest. No extra annotations or generators needed. You can see it right here on my screen. Alright, last but not least, generation type.auto. With this strategy, you're basically telling JPA, you decide the best way to generate IDs for me. JPA will look at your database dialect and persistence provider and pick the most appropriate strategy. Whether that's a sequence, identity column, or table generator. It's super handy when you don't want to lock yourself into one particular approach. And that's it. JPA will automatically choose identity, sequence, or table based on what your database supports. Alright, we've just covered all the generation type options. Now take a look at the @Generated_value annotation. You'll notice it has a generator property. Remember, you only need to specify the generator when you're using the table or sequence strategies. For identity, UUID, or auto, you can leave it out entirely. Okay, one more thing. JPA also supports custom generators for ID creation. We'll dive into that in a separate video where we'll walk through it with a real code demo. So stay tuned for that. Alright, let's move on. Open your employee class. Now, we know our employee ID is auto-generated. So, let's add the generation type.identity strategy to it. So, what happens when we use generation type.identity? Well, this strategy lets the database handle the ID generation. Done. Now, our employee ID will be automatically generated by the database. Alright, now let's continue and add @column annotations for the rest of the fields in our employee class. Alright, next field is employee name. This should map to the employee_name column in the database. See, in our table script, it's marked as not null. So we'll also set nullable equals false here. Okay, next up is the age field. This maps directly to the age column in our table, simple one. Alright, next is our joining date field. If you look at the table script, this column is called joining_date and it's marked as not null. So here I've specified the column name as joining_date. And set nullable equal to false to match the table constraint, because JPA won't allow null values in this field now. Okay, next is the department field. So in the database, this is supposed to be an enum, right? But in our employee class, I've just kept it as a simple string. I know. I'm being a little lazy here. Didn't feel like creating a separate enum class just for now. But honestly, in a real-world or production setup, always prefer using an enum in code for these kinds of fields. Why? Because that way, the code will only allow valid values, and it won't accidentally try to insert something invalid into the database. Now, let's map this department field to the department column in the database. Set nullable equals false because we don't want this field to be empty in our table. Next up, let's look at the created date field. So, according to our table script, the column name is created_date, and we want this field to only be inserted when a new record is created. Even it should not be updated on updates. Mapped this field to the created_date column. Set nullable equals false because we don't want it to be null. Add insertable equals false because we want the database to automatically handle this field when a new record is inserted. Essentially, we don't want JPA to try to insert this value. The database will handle it, especially if it's automatically generated, like with current_timestamp. Set updatable equals false because we don't want this field to be updated once it's set. This is usually the case for fields like created date, which should never change after the initial insertion. Alright, moving on. The column definition property can hold a lot more information. It lets you manually define the exact SQL column type and constraints that should be applied in the database. Now, it's not mandatory to use this property, but I like to keep it consistent with what's in our table script. It ensures that everything matches up. So copy the column definition from our table script and paste it into the column definition property here. Next up, we have modified date. If you look at the table script, you'll notice it's similar to created date. But here, we want the database to automatically update or insert the value whenever there is a modification or creation of a record. So, instead of manually managing this from our code or JPA, we want the database to handle it automatically. Map to modified_date. Set nullable false. Next, set insertable equals false, so JPA won't handle this during the insert. Set updatable false, so JPA won't handle this during the update. Next, add the column definition. Alright, our employee entity definition is now complete. Alright, let's quickly wrap up what we covered today. Today, we learned how to create a JPA entity, map it to a database table, and configure all the important column properties. We also explored how to define a primary key and use annotations like a generated value, at column, and at ID to control how JPA handles our entity fields. In the next video, we'll dive into saving data, how to persist an entity into the database using JPA. Thank you so much for watching. Don't forget to subscribe, hit that notification bell, and stay tuned for more.